A warm welcome to all. This is my Dream Academy, where knowledge shapes dreams. Here, we are driven by a passion to make complex concepts not only understandable, but also enjoyable. We believe that with the right guidance, every dream can take flight. We are devoted to fostering curiosity and nurturing intellect, and our mission is to create a place where learning is synonymous with fun. As we delve into the fascinating world of physics today, we embark on a journey to unlock the mysteries of electric charges and Coulomb's law. Diving right in, what exactly are electric charges? Well, electric charges are fundamental properties of matter. They come in two types: positive, like protons, and negative, like electrons. The intriguing thing here is how these charges are produced. Every atom contains an equal number of protons and electrons, which makes it neutral. However, when an atom loses or gains electrons, it becomes positively or negatively charged. This is electric charging in a nutshell. Now, what about the properties of charges? First and foremost, like charges repel each other, while unlike charges attract. Ever wondered why magnets stick to your fridge but repel each other when turned a certain way? That's the power of electric charges at play. It's not just magnets though. Electric charges are essential in everything from the static electricity that makes your hair stand on end to the lightning you see during a thunderstorm. So, we see that electric charges are the building blocks of many phenomena around us. Now that we understand electric charges, let's delve into Coulomb's law. This law, named after Charles Augustin de Coulomb, is a cornerstone in the study of electromagnetism. It describes how two particles carrying electric charges interact with each other. The law states that the force between two charged objects is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. In simpler terms, it means that the force increases if either of the charges increase, and it decreases as the distance between the charges increases. So, remember the properties of charges we discussed earlier? Well, they come into play here. Like charges repel each other with a force determined by Coulomb's law, while opposite charges attract each other with the same force. Coulomb's law, hence, is a fundamental rule governing the behavior of electric charges. To further solidify our understanding, we will now look at some examples. Imagine 2 point charges, each with a magnitude of 1 coulomb, separated by a distance of 1 meter. Coulomb's law tells us that the electric force between them is a whopping 9 billion newtons. That's enough force to lift the Eiffel Tower. This enormous force is due to the large magnitudes of the charges. In reality, common charges are much smaller. Now let's consider 2 electrons. Each has a charge of approximately negative 1.6 times 10 to the negative 19 coulombs. If they are 1 nanometer apart, the electric force between them is about 1/100th of a newton. That might not seem like much, but on the atomic scale, it's quite significant. Now, what happens if we double the distance between the charges? Well, according to Coulomb's law, the force decreases by a factor of 4. That's because the force varies inversely with the square of the distance. So, if we move our electrons 2 nanometers apart, the force drops to approximately 25 thousandths of a newton. And what if we change the sign of one of the charges? The force becomes attractive instead of repulsive. This is why opposite charges attract and like charges repel each other. Through these examples, we see Coulomb's law in action, enabling us to predict the forces between charges. Before we wrap up, let's quickly recap what we've learned today. We started off by grasping the basics of electric charges, understanding how they are produced and the fundamental properties that define them. We ventured into the realm of the unseen, the microscopic world where these charges interact and create the electric world we know. From there, we introduced you to the cornerstone of electrostatics, Coulomb's law. This fundamental law underpins the force between two charges and is key to understanding the electric interactions around us. We further delved into the application of Coulomb's law, illustrating its principles with relatable examples. We saw how it's not just a theoretical concept, but a practical tool that explains everyday phenomena. With this, we come to the end of our journey today. Remember, knowledge is power, and you are now empowered with a greater understanding of the electric world around you. Thank you for joining my Dream Academy, where we turn dreams into reality.